Friends, today we are going to start with methods and classes in detail. In the previous session, we have seen how classes are created, how objects are created, and how to call functions using those objects. Now we will see objects, methods, and classes in detail. What we will cover in this chapter is methods in detail, including method overloading, parameter passing, recursion, class in detail, access control, static keyword, one of Java's most important built-in class, that is string. First of all, we will start with overloading method. In Java, it is possible to define two or more methods with the same name, as long as whatever parameters you are passing to that method is different. When this is the case, the methods are said to be overloaded, and this process is called as method overloading. So same name will be given to all the methods that have same functionality, only the parameters that you are passing to that method will be different. Method overloading is one of the ways that Java supports polymorphism. So polymorphism is a main key concept of Java, that is one name multiple forms, and that is achieved using method overloading. If you have never used language that allows the overloading, it may be strange for you that how multiple methods can have same name. But as you will see, method overloading is very interesting topic of Java, and it is very exciting, and it is very useful feature, because when there are functionalities that operate on, that is the main core concept, and it operates upon only the different data types, you can provide the same name, and only parameters that you are passing to that method will be different. When an overloaded method is invoked, Java uses the type or number of argument as its guide to determine which version of overloaded method to actually call. These overloaded methods must differ in the type and or number of their parameters. So depending upon the parameters that you are passing, number of parameters you are passing, and data type of that parameters, and whatever the data that method is written, whatever the data type, maybe it is returning int or float or character and so on, depending upon structure of that method, Java will decide which method to call. So it must be different in the type and number of their parameters. When Java encounters a call to an overloaded method, it simply executes the version of the method whose parameters match the arguments in the call. So whenever you are calling from the main function or any other function to that particular method, depending upon the arguments, Java will decide to which method I should call. Example of method overloading, overload demo. Here one example, one method is void test. It has no parameters, so it will print only no parameters. Second method is having one parameter, integer parameter, so it will display that integer parameter. Third one is integer a comma integer b, two integer parameters. And lastly, the test method will have one double parameter, and it will return a into a. So in this case, method is this having same name test here. Here also it is test. Here also it is test, same spelling, same case we are providing, that is small case, to write down the test as a name. But the data type, that is, it is returning void. Number of parameters are blank. Data type this is returning is void. Number of parameters is int. Here void is returning plus two integer parameters, and it is returning here double and with one double parameter. So depending upon which structure we are calling, Java will decide which test method I should call. So this is the example. Overload demo object have been created, then double result. So I will store the result. Object.test. This is the first call to the first method. ob.test, then call to the second method. ob.test 10,20 to the third method, and last one is ob.test. ob.test 123.25. It is returning double, so the result is stored into double result, and this result is printed over here. So this is the output of this program. No parameters. I am passing here. Then 10, then 10, 20, and 123.25. 10, 20, 10. A is 10. Here, first of all, no parameters is displayed. Then A is 10 is displayed. AB is displayed, and double result, and also 123.25 into 123.25. Here is the result 15190.562. This is the method that return A into A. So as you can see, test is overloaded 4 times. The first version takes no parameters, second takes 1 integer parameter, third takes 2 integer parameters, and the fourth takes 1 double parameter. The fact that fourth version of test also returns a value is of no consequence relative to overloading, since return types do not play a role in overload resolution. So return type does not play any important role. Only the number of parameters and data type of parameters, those are passed to the method, where they will decide which method should I call. When an overloaded method is called, Java looks for a match between the arguments used to call the method and method's parameters. However, this match did not always be exact. What does this mean? In some cases, Java's automatic type conversions can play a role in overload resolution. For example, at some time you may have the data type that is passed while calling, it is not present in definition of function. So any related type can be converted, Java will check. So this type can be converted to any related method definition, Java will check and then decide which method should I call. For example, class overload demo here, same test method is provided, no parameters. Second is 2 parameters, integer A, integer B. Then overload test for a double parameter. So single int parameter is not here. So this void test method, second method is omitted. Then here double, inside test double A, it is printing double. So when I call int I is equal to 88, ob.test will call this first method that have no parameters. Then ob.test 10, 20 will call this method that has 2 parameters. And third one, ob.test I. So I value is 88. So it will go to ob.test I. But I is an integer value. So method with single integer parameter is not present here. So what it will do? It will invoke test of double. Why? Because int can be converted easily to double value. So it will call ob.test to double A, and this print system.out.println will be printed inside test double A colon value of A. So what is the output? First output is no parameters A and B 10, 20. Then inside test double A 88. Inside test double A 123.2. So this is the one call for integer converted to double, and this is the second call for actually double parameter. So this way automatic type conversion will take place. But when there is no method present matching exactly to the called definition. This version of overload demo does not define test of integer. Therefore, when test is called with an integer argument inside overload, no matching method is found, because test of integer we have omitted. However, Java can automatically convert integer to double, and this conversion can be used to resolve the call. And after test is not found, Java elevates I to double and then calls test of double. But when this will happen, if test of int is present, had been defined, it would have been called instead. So only if no exact match is found, then only Java will employ automatic type conversion. Otherwise, it will directly call whichever method definition is present. So now what is the question? Why should I overload? Why should I use method overloading? What is the usage? It is the one way that Java implements one interface, multiple methods paradigm. In languages like C, if suppose I need to find absolute value. So we are considering now languages those do not support method overloading, so that we will understand why should I overload. Suppose I need to find absolute value. Since C does not support method overloading, I will have functions, and for every function I need to remember its name, whose core functionality is same, only data type definition is different. But since I do not have method overloading in C available, so what I will do, absolute of integer, LABS absolute of long integer, FABS absolute of floating point value. But in Java I can have only one function name and different parameters, so I do not need to remember different function names for every data type. So I can only define ABS, ABS and ABS, which is already defined in the math class of Java. And whenever we are calling the function, depending upon the parameter and type of parameter we are passing, Java will call that appropriate method. So unlike other languages, we have to remember um, like other languages, we do not have to remember whatever we have written. So these names are actually same, only slight difference is there because their core functionality is same. But since C does not support method overloading, we had to create different method names, and those we had to remember. But in Java, we do not have to remember anything. Java standard class library math class already have defined method called ABS, and this method is overloaded by math class to handle all numeric types. Java determines which version of ABS to call based upon the type of argument. Although this example is simple, if you expand the concept, so you will know how it is complex to remember method names when your Java program is so much vast. So for these simple examples, you will not understand the usage of method overloading. But if you expand the concept, you can see how overloading can help you manage greater complexity, because several names have been reduced to one name and you have to remember only one name. One more important point to remember, this is the alert. There is no rule stating that overloaded methods must relate to one another. So if you are creating methods and you are providing their names, so you can have same names to all the methods, and it is no rule, there is no rule stating that overloaded methods must relate to one another. That is, their functionality should be same. There is no rule like that. But from a stylistic point of view, method overloading implies a relationship. Why? Because you can use the same name to overload unrelated methods. You should not. You can use the same name. So all unrelated methods, whatever you are processing, like you are adding, you are subtracting, you are multiplying, you are dividing, all these methods can have same name, but you should not. Because if you are providing same name like add to all, so you will not understand which method is actually adding, which method is actually subtracting, and so on. For example, if you are using you could use the name square to create a method that return the square of integer and square root of a floating point value. So there is a difference between square and square root. So you can use same name, but you will not understand which function is actually squaring the number and which function is actually making square root of a number. But these two operations are fundamentally different. So square is a different thing and square root is a different thing. And when you are applying this, you are applying method overloading in this manner, it will defeat its original purpose. So you should not use the same name for unrelated functions. You should only overload closely related operations. So you should remember this. The functions which is having core functionality same, like adding of two integer, adding of two float, subtracting, dividing of same their core functionality is same, only data type definition is different, number of parameters are different. Only in that case you should have same name to those functions, not anything else. Now I can also overload constructor. You can also overload constructor methods. In fact, for most real world classes that you create, overloaded constructor will be a norm, not the exception. So real world classes like real world Java applications, whatever that you will be creating, overloaded constructor will be the norm, not the exception. Why? Let's take a box example. I'm creating a box example, class box double width, double height, double depth that we have already seen in the previous session. This is the constructor for box. Now box constructor parameterized constructor we have defined like in the previous session, box double W double H double D, width is equal to W, height is equal to H, depth is equal to D. So local variables are width, height and depth, and instance variables are W, H and D. Compute and return the volume, width, height and depth. So now you are having only one parameterized constructor in this case. This constructor is box double W double H and double D. So while creating object, you cannot create it like this. Box OB is equal to new box. Why? Because default constructor is not present. Default constructor is overloaded by your parameterized constructor, which is having three parameters, double W, double H and double D. But what if you simply wanted a box and did not care or know what its initial dimensions were? So yeah, if suppose you are having a box and at that moment you do not know what are the initial dimensions of those box, or what if you want to be able to initialize a cube by specifying only one value that would be used for all three dimensions. So if it may be a case that you are initializing a cube as by specifying only one value that can be same for all three dimensions. What if in that case? Fortunately, the solution is simply overload the box constructor so that it handles the situations just described. Here is the program that contains improved version of box that does just that. So for example, in the previous example, we were having only one parameterized constructor, double W, double H and double T, and constructor used when no dimension specified. In that case, I will provide -1 for all the dimensions because it is an uninitialized box. So I do not know the dimensions at this case. So one constructor is box with 3 double parameters. Second constructor with no parameters. Every parameter is initialized to -1. Then constructor used when cube is created, box double length. So width and height and depth 3 will be initialized with the same value, that is length. Compute and return volume in the same way. So I can now create 3 different objects. First one is with 3 double parameters. Second one is no parameter, and third one is only one parameter, that is double. So all will be initialized to same value. And I will now compute the volume and display. My box 1.volume, volume of my box I will display. I will display my volume of my box 2. I will display volume of my cube. The output produced by this program is shown here. 3000 minus 1.0 and 343.0. As you can see, the proper overloaded constructor is called when you are calling from the main function depending upon the number of parameters and data type of parameters. Proper overloaded constructor is called, and when new is executed. When you are providing the keyword new, depending upon the parameters, that particular overloaded constructor is called. Now, using objects as a parameters. We have only been using simple types as parameters to methods. So simple types are what? Int double, float, character, boolean, and so on. These are the simple data types we have been using since far till now. However, it is both correct and common to pass objects to methods. For example, here we will pass object to method. There is a class test. Test integer I comma integer j. A is equal to I, B is equal to j. So this is the parameterized constructor of test class. Return true if O is equal to invoking object. So now I need to write a method if the object that is calling this method and object that I am passing to that method, this method, if both are same, then I want to return the value as true. If O dot A is equal to A and O dot B is equal to B, I will return false, else I will return true, else I will return false. Now in the main function, I have created objects, new test, three objects I am creating. First one is new test 100, 22. Second is 100, 22. And third one is -1 and -1. So I need to check the equality of these objects. How I will check them? Object 1 dot equals object 2. Equals means having both are having same values, right? So here I am having 122, and for object 2 also I am having 122. For the next one, 122, are they equal with -1? No. So these two objects are not equal. So this will generate the following output: object 1 is equal to object 2, true, and object 1 is equal to object 3 is false. Now, how this is possible? Equals method inside the test compares two objects for equality and return the result. That is, it compares the invoking object with the one that it is passed. Invoking object means whoever is calling that function, and one that is passed means whatever object that you are passing as a parameter to that method. If they contain same values, then the method returns true. Otherwise, it will return false. The parameter O in equals specifies test as its type. So you can pass any class object as a parameter to the method. Although test is a class type created by the program, it is used in just the same way as Java's built-in types. Test is a class type. Test is a class. It is not a primitive data type like int, float, character, boolean. But still, you can pass them as the same way as the Java's built-in types. One of the most common uses of object parameters involves constructor. Object parameter uses are constructor. You will want to construct a new object that will be same as a existing object. For that, you must define a constructor that takes as the object of its class as a parameter. So invoking object and the parameter object, they will be checked for equality. So this is usage of passing object as a parameter. When you need to check if both objects are equal or not. So now we will see the example of this. Here in this example, box allows one object to initialize another. I am creating one class box, double width, double height, and double depth. Now constructor, we will see. Box in bracket, box object. What is this constructor? Is it something different from the previous constructors? Yes, it is different. Why? Because it is passing construct. It is passing box object as a parameter. Pass object to constructor. So now, how I will check? Width is equal to object dot width. Height is equal to object dot height. Depth is equal to object dot depth. Now constructor used for when all dimensions specified. Like box double W double H double D. Same example is repeated, only this constructor is different, box and object box. Now constructor, when no dimensions are specified, all these values are initialized to -1. And constructor used when cube is created, box with double parameter. And all these width, height and depth are initialized to single double length value. Now compute and return the volume, width, height, depth multiplied. Now new box objects are created. Three objects are there. One is having three double parameters. One is having no parameter and one is having only one double value parameter. Now I am creating one more object that is same as a mybox1 object. So how I will create it? Box myclone is equal to new box mybox1. Create copy of mybox1 double volume. Get volume of first box. Volume is equal to mybox1 dot volume. So I will get the volume of three boxes. mybox2 dot volume, mycube dot volume, and get volume of clone volume also. So that will be same as your first one. Why? Because it is the exact copy of the object that we have already created with 10, 20 and 50. When you begin to create your own classes providing many forms of constructor, it is usually required to allow objects to be constructed in convenient and efficient manner. So as you go on creating different types of programs, you are going to create different types of Java applications. So in that case, providing many forms of constructors, multiple types of constructor, default constructor, parameterized constructor, and all these constructor with objects passed as a parameter is actually required to allow objects to be constructed in a convenient and efficient way or efficient manner. Now we will see argument passing in detail. So argument passing can be done in two ways: call by value, call by reference. Call by value copies the value of argument into the formal parameter of the subroutine or a method. Therefore, changes made to the parameter of the subroutine have no effect on the argument. Then call by reference, a reference to an argument, not the value of argument, is passed to the parameter. Inside the subroutine, this reference is used. Call by reference is reference to argument is passed, not the value of argument is passed. Inside the method, this reference is used to access the actual argument specified in the call. So reference is actually modifying the actual object. It is not operating upon the value. Call by value operates only upon the value that will be your temporary thing, and reference is used to access the actual argument that is passed. This means that changes made to the parameter will actually affect the argument used to call the subroutine. And Java uses the both approaches depending upon what is passed. In Java, when you pass a primitive type to method, it is passed by value. Thus, what occurs to the parameter that receives the argument has no effect outside the method. For example, here is an example. When you are passing parameter as by value, whatever you are whatever changes you are making inside that method, which is called by value, will not actually affect outside the method. It will not actually affect anything outside the method. So this is the example. Here class test is created. Method having two parameters, int I, int j. I is equal to I into 2 and j is equal to j divided by 2. So whatever you will be passing, I will be multiplied by 2 and stored into I, and j will be divided by 2 and stored into j. Then class call by value. Now I'm creating object of class test. Then int a is equal to 15, b is equal to 20. So before calling that function method, the output is value of a and b is printed, and after calling this method, value of a and b is printed. A and b before call is 15. After call, value should be modified, but this is not the case because we are actually passing the values. So I should be I into 2, that is 30, and j should be j divided by 2, 20 divided by 2, that is 10. But since it is a call by value method, the original value will remain same after call. Operations that occur inside method have no effect on the values a and b used in the call. Their values did not change to 30 and 10. When you pass an object to a method, the situation changes dramatically. Means what? Objects are passed by what is effectively called by reference. Called by reference means actual objects will be modified. Keep in mind that when you create a variable of class type, you are only creating a reference to an object. You are creating variable of class type means what? You are creating object of class. What we are doing, you are actually only creating reference to that object. So as we have seen in the previous classes theory part, object is actually like a memory pointer that actually relates to the memory, physical memory present. Okay, so that will be actually address. It is like a pointer means it is the address. Actually it is address. So whatever object reference is anything, that whatever you will operate upon that object, actual value of that object will change. When you pass a reference to that method, the parameter that receives it will refer to the same object as that referred to by argument. So whatever the argument you are passing as an object, so whatever changes you will be making to that object will modify that object completely. This effectively means that objects are passed to method by use of call by reference. Changes to the object inside the method do affect the object used as an argument. Whatever changes you are doing inside the method affect the object used in the argument. For example, class test AB, then integer I, integer j, a is equal to I, b is equal to j. Pass an object here. Method test object. Object dot a is equal to object dot a into 2. Object dot b is equal to object dot b divided by 2. So first method is this is the parameterized constructor to initialize values. Now I create 15 and 20. So my a will be 15 and b will be 20. So before calling object dot a, object dot b, before calling it, these values will be displayed, and object dot method object dot a and object dot b after call. This is written over here. So this will generate the output 15 by 15 20, and after call 30 and 10. Why 30 and 10? Because you are passing here object dot method object. You are calling using this object and you are passing the same object over here, and whatever changes that you are making to this object, that will be changed. Actions inside method have affected the object used as an argument. As a point of interest, when object reference is passed to a method, reference itself is passed by use of call by value. When object reference is passed to a method, means when you are passing an object as a parameter, the reference itself is passed by use of call by value. The reference itself means actually reference of object is passed. Since the value being passed refers to an object, the copy of that value still refer to the same object that is corresponding argument does. Value being passed refers to an object, so whatever changes that you are making to that object will be reflected. Actually, the copy of that value will still refer to the same object that its corresponding argument does. When primitive type is passed to a method, it is done by use of call by value. Objects are implicitly passed by use of call by reference. So when you are passing parameters, those are primitive types that will be called as call by value, and when you are passing objects as a parameter, that will be called as call by reference. Now returning objects. A method can return any type of data including class type that you create. So method can return any type. It can return int, it can return float, it can return double, all, or it can also return an object. For example, we will see our example increment by 10 method. Returns an object in which the value of a is 10 greater than it is in the invoking object. Now, class test. Here is one variable int a, test of integer I, a is equal to I, test increment by 10, test temp is equal to new test a plus 10. So new test temp is equal to new test a plus 10, return 10. So this method is returning object of class test. So how it is possible? We are creating one object and passing parameter a plus 10. Whatever the value of a is, I will increment by 10 and I will return this object. So how to call this? Firstly, I create test object 1 is equal to new test and I am passing 2 as a parameter. While I am passing 2, this constructor is called, then test object 2. Object 2 is equal to object 1 dot increment by 10. So if I increment by 10, 2 will become 12. Now I will print object 1 dot a, object 1 dot a, and object 2 dot a is equal to object 2 dot a. Object 2 dot a after second increase, first increase, and second increase. First increase will give me a result object 1 dot a 2 and object 2 dot a 12, and after second increase it will give me result as 22. So in this way we have seen different topics in this theory part 1, classes and methods in detail, theory part 1. In the next session we will see remaining parts in detail, and after that we will see the practical parts. So meet you in the next session. Thank you so much.